Hi, my name is Jordan Pierce. This is Ethan Black, and our senior project proposal for the 24-25 year is the bumper amp. This is essentially a guitar amp with built-in distortion pedals.
All right, so just like Jordan said, we will essentially be combining the technologies of a guitar amplifier and the technology within a distortion pedal into one single unit. And so our bumper amplifier will both be providing amplification from the signal of the guitar and amplifying that, and also it will be distorting the signal in the same way that a distortion pedal traditionally would. The reason we want to do that is combining the two technologies, we are able to create a solution that is much more cost effective because you're not going to have to buy two units and it's going to be much more efficient overall. So in doing this, we aim to create a solution that is much more budget friendly for beginners and for musicians that are on a budget. A lot of existing solutions we'll go over are much more expensive, and there aren't a lot of great solutions for providing that distortion in an analog form with a decent price tag. So that is essentially the basis of our project here.
Some key features of our amplifier will of course be the amplification of audio standard to a guitar amp. So that needs to take in a small low voltage input from a guitar and output a high voltage sound through a speaker. The audio control standard to an amp, so volume, gain, reverb, and any others that we would like to incorporate. Audio distortion comparable to a guitar pedal, so overdrive, crunch, fuzz. High quality sound is a must, and we of course need to keep that as affordable as possible. These two images here show a clean sine signal, and one of the distorted signals for something like an electric guitar. That one in particular would give you a tone similar to like a rock and roll guitar.
So like we said, with some existing solutions, you have to combine both an amplifier and a distortion pedal. So companies like Fender and Wilson, they have these amplifiers, but you can't use that alone to create the sound you want to get from an electric guitar. You have to combine that with the distortion pedal. So as you can see by some of these prices here, by the time you have combined your amplifier with a distortion pedal, you're going to spend around $300 and up. There are some examples of these distortion pedals that on their own are $300. Combining that with an amplifier, it gets very expensive very fast. So our concept essentially of combining the two into one, we expect to spend about $100 per unit once that would be in production. So in the future, if we were to take this to a production line setting where we're selling it to consumers, we would expect the entire package to cost somewhere around $100 or less. So combining that and putting that into retail is going to be much, much cheaper than existing solutions today. And it'll also incorporate a lot of audio quality with an analog system that existing digital systems do not have. And it's going to be something much more beneficial to a lot of musicians.
So there's going to be 5 key stages to our amplifier. The first being the power supply, which needs to take a 60 Hz 120 volt wall outlet input and stuff that into a DC converter that goes down to about 9 or 18 volts, perhaps both, depending on whether we need our distortion and amplifier circuitry on the same rails or on different rails. And the next stage is our switchboard, which is where our input signal will start out and feed into. That then feeds into the distortion circuitry, which will utilize signal processing circuitry to create the desired distorted signal. That then distorted signal will feed into the amplifier circuit, which is composed of BJT amplifiers, op amps, and power stage amplifiers to feed into a high power speaker. The speaker we're looking at is 8 ohms right now, but we could do anything from 4 to 8 ohms. So that's going to produce a pretty loud sound, and it's a pretty high power output.
So incorporating these technologies into one device, we will have a control board with 2 potentiometers. One will be controlling the volume going through the amplifier and then to the speaker on the output. And then we'll also have another potentiometer which will control the amount of distortion being processed through our distortion circuit. And then we'll also have a couple of switches and other things to control which distortion modes are being selected at the time. We have a couple examples here. On the left, we have just a simple diff amp circuit, which will be incorporated. We'll, of course, be designing our own version of that. And on the right, we also have an example of a distortion circuit, both of which we'll be designing our own, but we will have those 2 separate circuits within the device. We'll have separate circuits for the different distortions also. We will be using knowledge and skills that we've obtained in microelectronics 1 and 2. We'll also be using skills from signals and systems, also from control systems, and a little bit of power systems, all incorporated into this project.
So some of the key parts we're going to need are BJTs. I've selected pretty standard MPN and PNP BJTs. I estimate we'll need about 10, running at about 39 cents a piece on DigiKey. Power BJTs, however, cost quite a bit more. I found a pack of them for $7.89, but we'll just have to get that pack for prototyping. Manufacturing, that'll cost less. I found a case with multiple resistors, capacitors, and inductors, a pretty wide variety of each, for about $20. Again, these components in prototyping cost much more than they would in manufacturing, because we would have exactly what we need, but we're getting more than what we need for prototyping. Diodes for the power staging run about 9 cents a piece. We'll need about 10. Switches and potentiometers, we'll need a few of those, running about 14, 15. We could just buy a power supply as well if designing the power supply is overkill. One of those costs about $15. The chassis and PCB will cost $30 estimate. And for miscellaneous spending, I've allocated about $10 just for anything we don't know we need yet. The 8 ohm speaker is $30, making it the most expensive thing in this design. So we're going to have to be very careful when testing on that. Of course, all these prices are subject to tariffs and shipping costs, but the running total as of right now is $132.89.
Here we have an outline of our timeline expected for this project. For the first part, we have a significant portion allocated to the circuit design and simulation. In this portion, we will of course be aiming to emulate the signal distortion found on existing devices. We want to, as closely as possible, emulate that so that of course our end product, the end sound, is what we want. From there, with that design, we will go through our prototype assembly with our PCB design that we'll have sent and milled so that we can solder our components on there. And from there, we will start our first round of testing and debugging to make sure that everything is working properly. And we will then we'll measure and observe the output signal from there and make notes on what we need to change, make our alterations with that existing design, and then create our refined version for our final prototype. And then with that final prototype, we'll have the PCB made, soldered everything together, and verify that our output signals are coming out exactly how we want them to. Having done that, we will then, in our final stage, collect our documentation of our process and create our report for the final project.
We have a few options for financing, the main being university grants. We missed our deadline for applying for the university grant for the fall 25 grants, but we can always apply for the spring of 26, as that's when we'll likely be constructing most of our hardware. If that fails, crowdfunding is always an option. A project like this, I think, can attract a lot of attention with the music community, and I think it would be appealing and has a good chance at actually accruing some good funding on platforms like Kickstarter, for instance. And if that fails, there's the NSF Small Business Innovation Research Program, which is essentially a business grant to build a product. But that's, of course, more business oriented than academic. So it's not the greatest option in this case, so we'll likely not be applying for that one.